Hey MG, look, did you check out comments on your MLOps videos? Someone is actually asking... Wait. Recording? Psst. What? Aren't you recording? Why aren't you saying anything?
I have nothing to say, except one question from you actually.
Me? What?
Did you use my credit card for your Azure subscription?
What? Yes.
And did you check out your Azure bill?
No. Is it too much?
Check.
Listen, I had a machine learning project. I had to use Azure Machine Learning Workspace. I went through your MLOps videos. I went through Azure ML Pipeline Responsible AI videos. I applied all of them. I'm super happy, and I paid the compute that I needed for featureization and pre-processing and generating some features. And I had to do it. That was a part of my project.
That's fine if you have used them. But I just checked your Azure Machine Learning Workspace and your codes inside, which costed a lot. And I figured out you have produced the same features that I produced in my Azure Machine Learning project. And now we are paying for the same thing that we duplicated. 2 times paying for the same thing. Why did you do that?
What? How would I know you have generated the same features? I just saw some files with different formats on your side, and if I would know you have the features, I would use yours rather than paying again to generate the features.
Actually, you're right. Now I have something to say in this video. Have you ever heard about Feature Store?
Feature store? Feature store? No, what is it? I haven't heard about it.
Well, Feature Store is a central place to manage, build, and share your features across the teams within the organization. This is the solution of our situation.
Can we use it then in Azure Machine Learning? Feature store, I mean?
Of course. Actually, let's build it now. Hello everyone, this is MG and welcome back to another video which we are going to showcase you how you can use Feast as an open source feature store solution in your Azure Machine Learning Workspace that you can have a central place for managing, building, and sharing your features across the teams, not only just for offline training for the models, but also for real-time inferencing without being worried about duplicating the efforts and also having the issue of low latency when you have real-time predictions. Let's check it out.
Let's start with this page actually, which is talking about bringing Feature Store to Azure. I will also add this link to the video description YouTube channel so you can click on it, go through it, but I will provide a quick walkthrough on this page for you to have a little bit introduction on what we're going to cover in this video, and then we will see in hands-on how we can enable it on Azure Machine Learning. Well, there are mainly 3 challenges we face up when you're training our machine learning models. First of all, within a company, potentially I'm using a feature for my machine learning project. At the same time, there's another or multiple machine learning projects running at the same time, and potentially they're using the same features. But because these teams aren't aware that the feature already exists, so we have duplicated efforts. All those pre-processing will happen again within these projects to come up with the same feature, which is of course not efficient. That's one challenge. The second challenge is online and offline skew. What does that mean? When we talk about offline, that's the moment we use historical features to train a model, or when we do a batch prediction, which is not necessarily real time. that we want to use the same features that we use for training. I mean, not the same values, but the same structure of the data set and features types that we use for training. For inferencing on batch, we're going to do the same, but having that consistency of the features that we use for training to have the same structure, feature types coming for the inferencing can be challenging, specifically for online, which is the time that we have real-time inferencing. How we can make sure that point in time correctness is still applied, as it has been also mentioned here, and avoid any label leakage. If I have used the data set for training using those features, and now I am doing online prediction or real-time prediction, making sure that none of the features values that I use in training wouldn't come to my inferencing, which is of course a leakage. And we have to make sure what we are doing for inferencing hasn't been exactly duplicated in training data set. And having that consistency between the training phase and testing phase, regardless of being offline or online, can be challenging. And last but not least, when we are talking about real time, well, the first question is latency. Making sure that there is no low latency issue for the time that we're going to be pretty fast on predicting a value based on the input features that are coming real time, and we are providing predictions real time as well. So that can be even more, but here I just highlighted and quickly summarized some of the main challenges that we can have within the feature steps for our machine learning journey. Then how Feature Store can support us. Feature Store, we can consider it as a layer that we can add on the top of our machine learning project, mainly focusing on the feature section. That when we have multiple feature engineering efforts, let me actually focus on this nice figure, we can come up with multiple feature values out of those feature engineering process. And some of them can be used just for one machine learning model. Some of them can be shared between multiple machine learning models. So we don't need to actually duplicate those features again as we are sharing. And people know that which features are already available because of that feature store. And we're going to see how they can actually check that. And then for each, they will have their own inferencing. And as I mentioned here as well, some of them, when we do the inferencing, need to have the same configuration of the features that we use for training. If I have trained a model with 10 features, that doesn't make sense to, let's say, do the inferencing with the model and the input would be 20 features. Well, this is not what model was being trained and learned to come up with the prediction. Then what is the solution and how we can enable it? Well, Feast is an open source feature store solution that here we are going to leverage on Azure, and on backend we will come up with deploying some services that can provide us the mindset of feature store and also technically enabling that for our process. If I scroll down, here are the main components that we need to enable feature store. First of all, when we have data engineering, data scientists, they do some pre-processing on the top of the data. That can come from real time, that can come from some historical data stored somewhere. So they come up with some feature values. And these historical data or historical features can be reside in the SQL database, or here that can be Synapse as an example here, which we call it offline store, which we get the historical features out of it. That can be also an Azure storage, which we can also put unstructured data there as well, and even semi-structured data there. Or maybe sometimes we're getting this data from online data pipeline that are ingesting the data, that can be even an event hub here. But what we will have on the top of all of this is Feast registry. That's the place that we will register what we have available in both offline and online features as feature store. This file can be residing on blob storage when we actually do some prototyping, or in production environment we can have AKS or Azure Kubernetes as a solution for Feast registry section. But here for our scenario, we will go with the blob. So now when we have configured this and we have a feature store that actually is providing us a layer or a view on what we have available for offline and real-time ingestion and feature availability, then let's see how we can utilize this when we are training or inferencing a model. So coming to the feature provider section, what we have here is Feast feature provider. This is a client of a Python SDK. When we call this, it will go through this feature ingestion and registration and tell us that, hey MG, if you want to use that historical features, I know these are available here and these are the features you have defined before. So I'm not going to duplicate those features again. I know what is already available. And then I can get those and train my model based on historical features coming from that ingestion solution that we just talked about. And when we are going actually to do inferencing and now we need an online install, Azure Redis is provided here. Why? Azure Redis is a cache or in memory solution based on key value that can give us almost 99.999 I think availability for a very fast solution, specifically when you're doing real-time prediction. And that's why for online store, Azure Redis can be a good solution. So when we are doing a prediction for real time from Fist, I can detect that I have an online store on Redis. I can call that online store to get the input for inferencing in a very fast manner. That's how for both offline and online, I have a feature provider to give me the service and then come up with the model prediction or the training phase with getting historical features. Now for the components we just talked about in this table, for offline store, we talked about, for example, Synapse here, but it can be SQL database, AWS Gen 2, Azure SQL VM, so on and so forth. For online store, we talked about Azure Cache for Redis. I just mentioned what is it. That's one of the main advantages here, the availability. It is an in-memory cache, key value, so on and so forth. You can take a look at it to have a bit more feature on this service. And the registry, this is the place we're going to have that layer of the view of the features to register that, which we are going to use blob here. And of course, for machine learning platform, we will use Azure Machine Learning. All right, so now let's get started. Let's deploy this in our Azure environment and see how all these end-to-end solution will work when we're hands-on. So you can see here, there's a GitHub. Again, I'll post this on the video description so you can check that out, but let's click on it. And here are some examples that how we can enable Fist on Azure Machine Learning. So what will happen when we enable this? There's a nice architecture here that can explain a little bit more on that. So here are the components that we're going to deal with for this video. And you can see here at the center, Azure Blob is being used to register what we have available as a feature here, which is registered by Fist. So when I'm in my training phase, and let's say I'm here, I'm going to train a model, I want to see what features are available. So what can I do? I can use the Fist SDK to say, hey, give me some historical features, see what I have available. So it will go through that Azure Blob register store, Azure Blob that we have registered the features there as a feature store. It will give me back those features available. And then when I have those name of the features and I know what is available there, where they are stored, remember, this is our offline install, Synapse. I'll grab all the features in my Azure Machine Learning notebook, and Fist was being used as a layer to show what I have available. And when we deploy the model, when we are going in the online mode and we want to do inferencing, let's say real time, what I need to do, then the same type of features that I use now, I want to use the same type of features, but the fresh ones coming in as an input to do the prediction. That's why here, from that historical data which are coming in, I have materialized those using Fist in Azure Cache for Redis as an online store. So when I'm inferencing, again, I will use Fist SDK to call the features that I want, and I know what is available, and they will directly come from Redis, which are pretty fast. And as soon as I call, suddenly they come to my pipeline that I'm doing prediction, and the predicted value would be there available. All right, so if I scroll up, if I go to provider tutorials, this is the section actually we're going to step by step go through it and enable Fist in our Azure Machine Learning. So if I click on deploy to Azure, it is a very nice solution because as soon as I click on it, it will actually showcase me all the templates that if I click on creation, it will deploy all these components for me automatically. So I don't need to provision these services one by one myself. So let's click on this and see what's gonna happen. So I click on open new tab. It's asking me to sign in. And here's my Azure portal. And you can see there's a custom deployment with 11 resources. I can even see the templates there. Here I can choose a subscription that I want to enable. Let me choose mine. Then I will create a new resource group. I will call it feast test 1 2 3, anything, just an example. Then here I can choose a password. This is actually for some password we need, for example, for the Synapse. When you have a SQL pool there, you need a password to log in. So let me choose mine. All right. Now, what is principal ID? It specifies the principal ID assigned to the role. So what does that mean? If I get back to the GitHub again, it is telling me that the admin password, I just mentioned you, what is this? This is for that SQL pool. And the principal ID is being used for setting the storage permissions for the Feast registry store, which is basically that Azure blob. So if I run this command, this will give me the object ID for the sign in user, which is myself MG. So let's copy that. And then I have opened the portal here. I can open Cloud Shell and just paste it here. Okay, let's wait a bit. Succeeded. Connecting terminal, and there you go. So let's quickly paste it, enter, and there you go. Here is the value. So make sure you copy this. Right click, copy. And let's get back to our deployment. Okay, here's this principal ID. I click on it and Control V. So I pasted the values. Let's check if we have everything. Okay, these are some default values. You can certainly change it. For example, administrator login, you can change it to MG or whatever you want, but let's keep it as is. And I think I'm fine. Oh, actually, let's check the region as well. I want to have it in Canada Central. Clicking on review and create. So it is validating the inputs to make sure these are all fine. There is no inconsistency. Everything is working properly and perfect screen. So I can click on create and it will take potentially several minutes. So I'll pause recording, and when the deployment is done, I'll resume recording and we will go on from there. All right, the deployment is over. You can see the deployment is complete now, and I can go to that resource group that I just deployed, and you can see all the components that I just showed you in that GitHub is now created for me, which is Azure Machine Learning with the all component coming with, for example, Azure Key Vault, Azure Content Registry, Application Insight. You can see I have storage accounts. One of them is coming for Azure ML. The other one is actually the one that I will use to store my feature or feast registry there. And the other one that comes with my Synapse. And here's a SQL pool that comes with Synapse, which I'm going to have my historical features there. So let's open Azure Machine Learning. And the nice thing about this template that we just deployed is that it not only deployed the resources for me, but also it is doing two more things for me. First, it will create a compute instance inside the Azure Machine Learning. So we will see when we open that, it should be already there available. Let me actually launch Azure Machine Learning that we created using this deployment. Let's see if it's there or not. We go to compute. There you go. There's already a compute instance created running for me. Perfect. And the other thing is all these services need to talk with each other, right? So we need to have, for example, the SQL pool credentials to get access to it through the feast and get the historical data, or for the Azure Cache, the same thing. All these credentials are stored automatically in the default key vault that is coming with Azure ML, which is basically here. So we don't need to register them again. We just need to call them through that key vault. And that's it. So what we need to do, first, let's clone these GitHub. And then we have some tutorial and notebooks there so we can walk through them and deploy. Let me copy this and get back to our Azure Machine Learning that we just created. Open a terminal. And here it should give me a terminal access. There you go. I can just paste what we copied, and Git is already enabled for me in this compute instance. So if I hit enter, you can see that the Feast Azure GitHub that we just went through it is getting all cloned for me, that I will have access in my working directory. And that's how you can see it is already creating a folder for me. So let's wait to make sure all the files are all cloned here, and we'll check them out. All right, 100% complete, done. And let's do a quick refresh, and you can see there's a folder called Feast Azure. Remember, I went to the provider tutorial, and there we go. We have the notebooks that we can start from part 1, then 2 and 3. What is part 1? So here you can see my compute is running properly. Also, as mentioned in the GitHub, make sure this is selected as Python 3.8. And what we're going to do first, we're going to generate some data and create them as a table to push them to the Synapse, which is the place that we pull that our historical features reside in. So what we're going to do here, we're using SQL Alchemy. This is actually a library that I can use to connect to a SQL database, right? So I'm connecting to my workspace, and I need to access to the key vault because the credentials that I need to connect to that SQL database is already stored in the key vault, and the template did it for us, as I mentioned. And using create engine coming from this library, I can then say that, hey, this is the offline store credentials needed to connect to that SQL database, and then create this connection for me. So let's execute this. It should take just a couple of seconds, and then you should be fine. Awesome. The connection is created inside engine. So what you're going to do right now, first, I'm going to execute some SQL codes. Where they are, they're inside SQL folder, and this is the SQL code that I have here. Let's actually take a very quick look. So I have SQL folder here. The first one that I'm going to execute is this query, which is coming from this one. Let's open it. Create CX profile table. Let's open it. You can see here, this is basically SQL code creating a table for me with these columns, date, time, customer ID, so on and so forth. And that's it. This is the distribution type. So this is simply creating a table for me. After that, I am executing another query, which is another file, which is load CX profile data. Let's see what is this one. This is again inside SQL, so it should be here. Load CX profile data. There you go. And here you can see that it is actually referring to a storage account, which is a blob, and asking that there is a CSV file that we have all customer profile data. Grab it and then load it to that customer profile that we just created using the previous SQL code. So what I'm going to tell you is that when I execute this cell, it will go to my Synapse, the SQL pool that I have created, create a table, call it, I think customer profile, and then load the data from the CSV file in blob to that table. So using that connection we just created above, let's execute this. There you go. It's telling me that creating customer profile table is created. Now it is loading the data from that CSV file to the customer profile table, and done. And here's a quick view selecting the top 10s from that customer profile. It's a SQL query, and you can see this is the table that is created for me. Similarly, there are more SQL codes that we are going to execute which create different tables and load the same thing from CSV file to that table. Exactly the same thing that we did to create customer profile. And now we're going to create another table for drivers, load the same thing. So let's run it. And last thing, the orders table, and we create and we load the data. And we will see the top 10 rows from that table. And I'm going to talk about what these tables are. And let's do the last one. There you go, done. So let's see what are these data sets. Let's scroll up. So what we are going to do, we are going to train a machine learning model that will predict, actually, before there are three tables that we're going to use, and here the main purpose is predicting whether a driver will complete a trip based on the number of features that we have, and we're going to use Feast for it. So what are the tables there to support creating a model to predict if a trip will be complete or not? Well, the first one is customer profile. We just created here, right? So this is basically some information about the customer entity. For example, what is the average number of passengers per trip? We can see here. The second one is the driver entity. For example, what is the average number of daily trips for that driver or ID within that date or time? And the last one, which is actually the fact table or order table, is the information about using the driver and customer ID, whether the trip was completed or not, 0 or 1, right? So now all these tables should be created in our historical store, which is Synapse. Let's check that out. Let's go to like my Synapse workspace. Let me open my Synapse Studio, and we should be able to see there's a SQL pool created using that deployment file, and the table should be created because we ran those code in Azure ML and we connected to this SQL database. You can see there's a SQL database created here, and if I click on this arrow, you can see tables. And there you go. We have customer profile, driver, hourly, and orders. Let's do a quick select top from the customer profile, making sure data is there. There you go. The same data, we just saw in Azure ML. Now they have been appeared there. Now, what's the next step? Part 2. Let's open it. Can you guess what? That's the time that we're going to register our features. And remember, we went through that. We talked about the components we will utilize. So let's check it out, what we're going to do here. As we talked, for registering the features as a feature store, we will use Azure Blob storage. There's a blob created for us. I'll show you that. We register the features there, and this is the place we grab it to have a view of what features we have available. Please note, as is mentioned here as well, the best way to register features is through CI/CD. For example, when the development of the code is over, you want to do a pull request to push your data to a repository, you have to make sure at the same time you're registering the features as well when your codes and process is approved. So we have a view of what features you have created, so other teams, other models can also leverage them as well. Let's scroll down. For registering and configuring a feature store, we need certainly a feature store configuration file, which is coming from that YAML. Let me execute and see what is inside this YAML file, inside this folder, which is here actually, feature repo, and this is the YAML file. You can see that we have the information, some infrastructural configurations to how and where the registry file is located that can connect to the dataset using the strings there. For example, it is telling me that the feature store will be stored in Azure Blob storage, and this is the path to that. The next one is, for example, what is the online store provider? We talked about it. This is Redis. This is the credentials, and the offline store we went through the Synapse and we had the SQL server there, and this is the SQL connection. You might ask that where these values are coming from. These are operating system environment variables that we can define from getting these credentials using the key vault that we have there. I'll show you quickly how we can do this. So now we have a YAML file, we know how to configure our feature store, then let's do so. Connect to feature store. What we're gonna do, we will connect to our workspace, we will get access to the key vault that we have those credentials, and then after getting the place that we're going to register Feast, the credentials to my SQL database, which is my offline, and also Redis, which is my online solution. They're already available in my key vault using deployment file we configured, and we push it to our environment as a variable. So when we execute this YAML file, then the YAML file knows what those values are. Let's execute this. Oh, by the way, again, make sure 3.8 is selected here. That was my mistake. Okay, let's execute this again. There you go, no issues so far. Sounds great, done. And the next step is defining the data store. First, we're going to define what is the offline store. So the first thing for creating an offline store is saying that where is your offline store, right? So from Feast Azure, we are importing MS SQL Server source, and we're going to use this to tell that, hey, I have a driver source data that is inside SQL, and here I'm defining that, well, this is the name of a table or the reference of that, which I have defined here. That's the same name we use in the Synapse. I just show you the tables, and I'm telling that this is the timestamp column and the created one if exists, which here we just put nothing, but here we can say the created column is the created timestamp. That's it. So I have defined the sources that where's my offline store for registering that. For registering a feature in feature store, we need actually two things. We need to define what is a feature view and what is the entity. Let me describe what are these. First, what is feature view? Feature view can be a logical combination of group of time series feature data that they're all coming from that data source. As you can see here, for example, I'm creating a feature view for the driver status. I'm giving that a name and think that this is the entity for that. I'll come back to this what is entity. And for this feature view, these are the features that I have and the type of them available there. Where is the source? Well, the source, we just defined them here using the SQL Server connection, right? The same thing for the customer profile. Do you define the entity, the feature name, and what is the time delta between these variables? This is important for having the consistency. And again, when we register feature, that doesn't mean feature store generate features for us. This is just a serving layer. Whatever is happening to create the features is on the compute side that we have, that can be SQL Server or Redis or whatever we are using on backend. So we are just creating a serving or ingestion layer on the top of that. So now what about entity? We defined them here, but what are those entities here? This is actually where I'm defining the entity within the same name that I have defined on the top, customer ID and driver. And basically, entity can be a collection of related features. For example, here I'm saying that this is the entity driver, and using driver ID, I am potentially joining multiple features to come up with the entity and the view that I would like to have to call the driver from the source that I have defined on the top that I just showed you. So later on, when I want to identify a feature to store or actually retrieve that feature from features using feature store, entity will be my primary key to call that. So when I have defined those, let me actually execute this. Oh, it's not defined on the top because I forgot to actually run the cells. Okay, that was the last thing I ran. So I described this. Let me run it. Then here's a place we define the feature view. Done. And here we're defining the entity. Done. And that's the time that we're going to click on FS or feature store apply. So what's going to happen here? Remember, we define the feature source, which is SQL database. We define the feature view and an entity for those feature view, and that's the time we're going to apply. What will happen? The feast will go and scale all the files in feature repository to find out where is your feature repository to update and add the feature view entities you are creating from the data source. If it's not there, which is the case for us because that's the first time we are creating a feature analytical feature store, it will actually generate a feature store object, register that, then update that feature registry, what features we have available, which is the driver and customer that we just talked about. So let's execute this cell. Let's wait for it. Done. So if I go to the storage account that we registered this feature store, we will see that there's a registry.db that contains the metadata of the features that we just registered on the top. Let's actually check that. That should be fun. Okay, where is my portal? Getting back to my resource group. I think this should be the one. Yes, this is the one that we use for feature registry. Containers. There is a container called feature store registry container. And there you go. There's registry.db. I don't think we can see this because some of the information is showcasing properly because of the format. But actually, if I go back to my notebook, here's actually this code will showcase the same thing, telling that, hey, you have these features available. Now you have registered driver feature with this entity. These are the features and the type of them that you have. And this is the source that you have available, which is SQL. The same thing for the other feature that we created. So now, as a person who are going to train a model, I know what are availables, and I'm not going to duplicate these features again. So I know the driver, for example, or customer profile features are available with this information. Perfect. I can grab them and not necessarily generating them again. So what is the next step? Now we are going to train a model using these features that is registered, and I'm not going to create these features again because they're already there. So I click on the third or part 3 notebook, which is the last part. Again, make sure this is on 3.8. So now what we are going to do very quickly, I'm going to train a model, but before that I want to see what I have available, what to discover what features I have available. So I connect to my feature store that we just registered. We saw that file. I want to see what features are available. Then I'm gonna train my model using the offline store, which is that SQL database, using get historical features function from Fist. Then I want to create the online version of that. So with using Fist materialize, I will push these features from offline SQL database to online, which is Redis. Why? Because I want to use the online store in my inferencing time, which is a real-time prediction. So when I deploy my model and I want to inference the model, do the prediction, I will connect to the online store using this function to do the prediction. So let's start from the first step, which is accessing to feature store. Again, these credentials are available in my operating system from Key Vault. We just generated that before using connected to this Key Vault, and here I'm just connecting to my workspace. Let's execute. Perfect. I have been connected to my feature store using this file, which is feature repo, and now, which I have it available here. And now here I can see the list of features available with just a very simple line of code. Here I can see, perfect, I have this feature, I have this feature. Remember, these are what we created and registered in the last notebook in part 2, and all the information available for me, the feature values, and also the type of those features. And now I want to get historical features from that SQL database and create a table out of it. You can see that I'm not going to go ahead and manually figure out those tables in Synapse, download them, save it somewhere, load them back again. Because I am using feature store as a layer, then I can use that layer to quickly, with just a query, execute the features that I want from that feature, from the entity that we define, and the features that we have defined under the entity. I'm good to go. Then I'm creating a data frame out of it. So let's execute. Certainly in real project that can be much more complicated, but here's just an example that a table will be my feature that I'm going to create here. All right, I got all the features that I want from the historical features function that is coming from my SQL database using the feature registry. That's the time I can train a model, and here I'm using MLflow to track it. I'm giving it the experiment name, connecting to the workspace, some MLflow configurations. Hey, this is my training that I've just defined on the top, and it's splitting that for train and test. Pretty simple, using scikit-learn, and then just a random forest classifier to say if that driver will complete the trip or not, yes or no. So that's a classification, and just train the model here using fit. There you go. Let me execute. It might take a couple of minutes, maybe just pause the recording, and I'm resuming the recording again. The model is done with the training, very simple. And here I'm going to register the model in Azure Machine Learning. So if you haven't checked the MLOps videos on Azure, I have explained all these components on Azure ML, how you can register a model, so on and so forth. For this model registry, it is just simply saying that this is the model that I like, I want to register it, because then afterwards I'm going to deploy. So I execute this cell, my model should be registered, and that's the time that I want to deploy a model. But before, When I deploy the model, I want to do real-time prediction using an online store, which is Redis. Low latency, remember? So I'm using this function to push the data to an online store. For sure, for real-time, date and time is important. This is what also is fist based on the top of that. And I have the time delta I'm defining based on the start and end date to push the data there, and feast.materialize will push the data from that source to the Redis. So I execute. There you go. It's nice showing me that it's done in just 2 seconds. And I want to deploy my model. But before doing so, we need to do something. Because we are going to use feast actually and feast registry, even for the inferencing phase when we have the online prediction, then we need to be able to authenticate and have access to that blob storage that has the feast registry, which is here. Remember, this is my container. That's why for doing so, we need to actually create a service principal, which is basically imagine that that's a kind of ID that we will let that ID to have access to that blob as a storage blob data contributor using these information that we're going to create and have it here. With doing so, then we will use that permission that we're going to create for that service principal to authenticate to that storage that has the feast registry. So when we do the deployment and inferencing, we should be fine to grab it. So how we create a service principal then? It's pretty simple. Let me get back to my Azure. You go to Azure Active Directory and app registration, new registration. Here I'm giving the name, for example, SP or service principal feast test 1, 2, 3, anything, right? And then I click on register. It should be pretty fast, usually after a couple of seconds. Done, creation completed. Now I need to copy something. Let's get back to the notebook. It is telling me that copy Azure Client ID, tenant ID, and client secret, and paste them here. And this is nothing, just a configuration of how I'm gonna deploy the model. I need this memory, these CPU cores as an Azure container instance using this environment that I'm defining, and I'm good to go. And I have some inferencing configuration in this GitHub, which is basically the environment requirements, the requirements of the environment needed to deploy the model. So I'm not going to define them here. It is already defined for me as well. I think it should be inside inferencing folder. Let me check. Inferencing Docker file. Yes, there you go. That's here, which I have it there. And as you can see, these are the configurations that I need. The packages, we certainly need Feast, so on and so forth, the Python version. So I'm not going to create that again. It's already available. So let's get back to my notebook. Oh, now I have so many tabs. Okay, the first thing that I need, client ID. Let's get back to the tab that we have created this service principal. The first one is client ID. I copy this, get back to my notebook, paste it here. There you go. Azure tenant ID. Let's get back to my app, which the tenant ID is here. And then the last one is a secret. How can I create a secret for service principal? Well, very simple. Getting back to my, oh, I have so many tabs. Okay, service principal that I created. If I click on certificates and secrets on the left side and generate new client secret, description, let's add test, click on add. And here's the value of the secret. I copy this, going back to my notebook, paste them here. Oh, I think I didn't paste that properly. Let me make sure. Okay, yeah, everything should be fine. And done. So we have copied the main 3 thing that we want. Let's make sure we can execute this. Configuration is done, and that's the moment we are going to deploy. And here's the scoring Python code, which is available already here from the GitHub, that is actually creating those connections, as you can see again, to the SQL database, to the Redis. This is the way that we're grabbing the data for online applications. And also here's the place that we have registered the feature store, which is the blob. Again, we're getting that from the operating system, and we're loading the model, generating the features from the online features. You can see that now I'm using Fist for grabbing the data in real time and then returning the prediction. Let's get back to my code, which is deploying the model. It will take a couple of minutes because we are creating a container instance to deploy the model. And when it's done, it should tell me that your model is deployed, and I will have an endpoint to call the model and do the input, call the input data from these entities that I have defined before, and it should grab these features in real time very fast from Redis, give it to the model, and then do the prediction.
All right, we just saw that how we were able to leverage Feast as an open source feature store solution in our Azure Machine Learning workspace that can be used for both offline training for the models and also even real-time inferencing without being worried about low latency or duplicating the efforts. We hope that you enjoy. What? I'm talking.
I know.
What is
Listen, I know that was my fault. So give me your email. I'm gonna e-transfer to you what you paid for my Azure Machine Learning, okay? And I'm sorry for that.
That's fine. You can keep it. Just make sure as of now you will follow what we covered in this video as a solution. Okay?
You are the best, MG.
I know. Then, okay. Until next video. See you later.